Ever wonder what powers the massive systems that run our world? Well, today we're going to crack open a hidden giant, a main diesel generator engine. We're going to try and understand its incredibly complex world through the one document that matters most to the person in charge, the instruction manual. Let's dive right in.
So just what does it take to control a beast like this? Get this. The engine we're looking at has a lubricating oil capacity of 1,400 liters. I mean, that's the kind of massive scale we're dealing with here. A machine of absolutely immense power and complexity.
You know, these things aren't just engines. They are the unseen hearts of our global infrastructure. Think about it. From giant ships crossing oceans to the power plants that keep all our lights on, these behemoths are constantly working away, just out of say.
All right, so let's properly meet the main character of our story, the powerhouse itself. And this thing is a true marvel of heavy engineering, really a symphony of steel and raw power.
Just look at the sheer scale of these parts. At its core, you've got this solid, forged crankshaft. That's basically the engine's spine. Then there's a massive flywheel, storing incredible rotational energy, a turbocharger and air cooler system that literally force feeds the engine air. And on top of all that, multiple high-pressure systems pumping all its different lifebloods. It's an orchestra of huge, powerful, moving parts.
So, with all these unbelievably powerful components, how on earth does a single person control it all? Well, they have a guide. But this is not just any old manual. For the engineer, this thing is the operator's Bible. It's the sacred text for taming the beast.
And this book, it lays out everything. It's a super detailed map that covers every single safety warning, every operational step, and every maintenance ritual. Because in this world of immense power and potential danger, you don't guess, you follow the book to the letter.
And the manual, it really doesn't waste any time getting to the point. Right at the beginning, it lays out the stakes in no uncertain terms. This isn't a friendly suggestion, it's a stark warning. One mistake can be the last one you ever make.
The manual just hammers home the physical dangers over and over. You've got the flywheel and couplings moving at incredible speeds, and the warning is blunt. Get too close and the machine can literally pull you in. The real takeaway here? Constant awareness isn't a good idea. It's a requirement for survival.
And it's not just the moving parts you have to worry about. The whole engine is basically a tinderbox of hazards. You've got extremely hot surfaces right next to flammable oil and high-pressure fuel lines. A single tiny leak in the wrong place could lead to a catastrophic fire.
So, with all those dangers understood, how do you even bring this machine to life? It's not like turning a key in your car, that's for sure. No, it's a careful, precise ritual that we're going to call waking the beast.
This sequence here is absolutely critical. First, you prime the whole system with lubricating oil for at least 5 minutes. You have to make sure every moving part is ready to go. Next, you have to meticulously check every single valve. Fuel lines open, cooling lines open, starting air closed. Then you activate the brain, all the protective circuits and alarms. And only then, when everything is perfect, do you engage the starting air, that powerful burst that finally begins the engine's rotation.
And there's a very, very good reason why this procedure is so rigid. If the engine fails to start, unburned fuel can build up as a fine mist inside the hot exhaust manifold. The next time you try to start it up, you could ignite that mist, causing a fire or even a massive explosion.
So, after all the checks, the priming, and that careful burst of starting air, the low-speed relay finally kicks in. The beast is awake. The engine is officially operating. But for the operator, the job has really just begun.
Now that it's up and running, a whole new challenge emerges, managing the extreme forces and temperatures that are raging inside the engine. It's this constant battle of, well, taming the elements.
A huge part of that battle is cooling. The manual lays out two main approaches. The simplex system is pretty straightforward. It just uses fresh water for everything. But the duplex system is a bit more resourceful, especially on ships. It uses fresh water for the supercritical engine jacket, but then it uses readily available seawater to cool the oil and the air.
And let me tell you, cooling is absolutely vital. The engineer is constantly walking this tightrope between two insane thermal extremes.
Okay, so on one hand, you have the air coming into the engine. According to the manual, the ideal temperature for that intake air is around 45 degrees Celsius. That's about 113 Fahrenheit. Pretty warm, sure, but manageable.
But on the other hand, The exhaust gas leaving the cylinders can reach a scorching 450 degrees Celsius. We're talking over 840 degrees Fahrenheit. The engine is literally living between these two extremes, and it is the operator's job to maintain that perfect, delicate balance.
Yeah, running this engine is not a set-it-and-forget-it kind of task. It requires this relentless, ongoing state of attention, a constant vigil.
You can really get a glimpse into the operator's life here. It's a constant dialogue with the machine. Every single day, they're measuring performance data, listening for any little sign of trouble. Every few hundred hours, they're cleaning the turbocharger to help the engine breathe properly. And then you have the major checkups, like measuring the crankshaft's deflection, just to make sure the engine's very core is still healthy.
And even this routine maintenance is just loaded with peril. When you're testing a fuel injector, for example, the fuel spray is under such high pressure that it can actually pierce your skin. The manual is crystal clear. A moment of carelessness during a simple test can lead to a really serious injury.
So after hours or maybe even days of relentless work, the time comes to let the beast rest. But just like waking it up, putting it to sleep requires a critical procedure. It has to be a gentle stop.
And this part is so critical. After the engine stops combusting, the work isn't over. The turbocharger is still spinning at incredibly high speeds just from inertia. So the manual demands that the lubricating oil and cooling pumps keep running for another 20 minutes to gently cool it down. If you cut the oil supply too soon, you'd completely destroy its bearings.
But what if there's an emergency stop? Well, the stakes get even higher. If the engine is running on heavy fuel oil, which is basically thick, tar-like stuff at room temperature, the operator has one critical task they must do: immediately switch over and flush the entire system with lighter diesel fuel. If they don't, that heavy fuel will solidify in the pipes as the engine cools, turning into virtual concrete and making the entire engine completely inoperable.
And that kind of brings us to our final thought. Looking through this manual, we've seen the danger, the precision, and the constant vigilance it takes to operate just one of these machines. They truly are the invisible, powerful hearts of our modern world. Which really just leaves us with one question. What happens to all of us when that heart stops beating?